Welcome back, critical thinkers. Today's TEKG3B. Determine the image or pre-image of a given two-dimensional figure under a composition of rigid transformations, a composition of non-rigid transformations, and a composition of both, including dilations where the center can be any point in the plane. So today, this video is going to cover constructing a dilation, how you actually draw it. And so our learning objective is to construct a dilation. And you will know you've accomplished this objective when you can actually be given a line segment, a triangle, a polygon, and you can actually take that, be given a scale factor, and then use that scale factor to make something bigger or smaller. Every skill that you learn in this video makes you a stronger problem solver. Now, I know you can do this, so let's turn your practice into your superpower. We're going to jump right in and start solving a problem. We're actually going to draw or construct a dilation. So the problem reads, dilate line segment AB, where A is at -9.7 and B is at 3.9. And we're going to use C, -2, -2, as our center of dilation. So everything starts at that center of dilation. And we're going to do this with a scale factor of 1/2. So our image is going to be 1/2 the size of our original pre-image. We are going to do a dilation where we have a line segment A, B, and we're going to take that line segment and we're going to make it smaller or bigger because that's what a dilation does. In order to do a dilation, you need to have a center of dilation, and our center is located at -2, -2. Our line segment has an endpoint A at -9.7 and another endpoint at B, 3.9. Whenever we do a dilation, we are going to draw a line from the endpoint to the center of dilation. So we are going to go to the center, and we're going to go to and through the endpoint. Make it go the entire length of the page, okay? We're going to do that with the other endpoint. We are going to take C, connect it to A, and we are going to go out the entire length of the page. Using colored pencils is essential. You really get to see what's going on a little bit better when color is used. So here we have the center of dilation right here, and we have the initial line segment AB that we are dilating. Now, anything that is below the line segment, so anything that goes from the line segment to the center of dilation would decrease the size of that line segment. Anything that moves beyond the line segment and goes outward is going to increase that line segment. So if we wanted to decrease this line segment, so let's say this is our pre-image right here, and we wanted to draw an image that was smaller, and let's say we wanted to do something that had a K value or a scale factor of 1/2. What we would do is we would measure this distance from C to A, and we would cut it in half. Then we would measure the distance from C to B, and we would cut that in half. Now, you could measure that distance with a ruler, and the easiest way to do that would be using the centimeter scale. And so you would put the 0 on the center, and then you would measure out, and you would find out what the length of CB is, and then you would divide that into 2. Another way of doing it is simply to grab a note card, and you'll put the corner of the note card on C, and whenever we get out to that point B, I will put a mark here. I will put a B there to remind me that it's B. And what I'm going to do then is I'm going to take this and I'm going to fold that note card in half. When I fold that note card in half, what's happening is I'm finding the midpoint of that segment. And so I am just going to mark where that midpoint would be, which is right here. And I'm going to put a mark. I'm going to come over and I'm going to do the same on the other side. I'm going to take C to A. I'm going to mark A right here. And then I'm just going to fold it up to the A, crease it, so I can see where that midpoint is going to be on CA. And I found it. It is right here. And so I'm going to mark it. Now, this dot right here is going to be my A prime, and this dot right here will be my B prime. I'm going to connect A prime to B prime. Draw my line. And now my image right here will be exactly 1/2 of the pre-image that is up here. So when I move toward the center of dilation, I decrease the size of the pre-image. So as I get closer and closer and closer to this center of dilation, what happens is the pre-image gets smaller and smaller and smaller and smaller, or the image gets smaller and smaller and smaller. As I move farther and farther and farther away, as my K value moves beyond 1, what happens is the image gets bigger and bigger and bigger. One thing that I want you to see is that if we're looking at the image and the pre-image, notice that the pre-image and the image are parallel lines. They have to be. So if you're ever doing a dilation and you get an image or a pre-image that doesn't look parallel, you know you've done something wrong. So as we move closer to the center, the image gets smaller. As we move farther away from the pre-image out from the center, it gets larger, and the two lines have to be parallel. This is it for today's video. If something doesn't make sense, if doing and constructing a dilation, if you're so confused that you don't know how to do it, that's your cue to ask some questions. In fact, it's your responsibility to ask questions. Now, you can come and talk with me, you can talk with your classmates, ask your shoulder partner, or you can even ask AI for a step-by-step explanation. Please remember that we're a team here, and we're all here to help one another succeed. You learn best by breaking complex concepts down into small, more manageable skills. And that's exactly what we did today. You are turning your practice into your superpower. Now, you know that I believe in you, and I know that you can do this. You are working your way to success one skill at a time. I want you to have a great day, and thank you for working with me.